that bug on your
I just started recording.
What are you laughing at? Huh? What are you laughing at?
I have no eardrums left.
Oh my god. I just started recording. Sorry guys.
God. I thought a huge spider was off. I was expecting to see something like that.
It was huge.
It was a grasshopper.
Well, everybody's woke up today, that's for sure. Now pass the laptop down there for people who can't see it. Right now.
Nope, filming stuff.
Okay, today we're going to learn about some pH. Anybody know anything about pH in particular? Anything at all?
0 to 14 scale.
0 to 14 scale?
7 is...
7 is a normal pH level.
Who's ever heard of the dead zone in the Gulf of Mexico where the Mississippi Delta runs into the Gulf there? Alrighty, that's a region where all the fertilizer runoff from the Mississippi River Basin, which is like all the floodwaters or all the water tributaries in the Mississippi, drain into the Mississippi. And what causes that dead zone is fertilizers like nitrogen and phosphorus and potash and different stuff like that fluctuating the pH level. And a dramatic fluctuation in the pH level kills fish. And that's why it's called the dead zone, because all that water is going into the ocean right there, and it's a really high concentration of a pH level drastic change. So today I got some lime, pond water, and nitrogen. And we're going to test the pH level of this. Now, to save time, because it takes 3 minutes to test each one of these, I've already tested the pond water. The pond water is about at around 7, 7.5. So 7, 7.5 is kind of the normal range for a stream, as y'all can see on that chart. I'll pass it down there in a little bit. So I'm going to pour some pond water at each one of these. Alright, I'm going to pond water here. Now this came out of the pond down at the beef unit where I work. And so it's just pond water. There's fish in there, shell cracker and crappie. So it's got fish thriving in it right now. Now this right here is lime. It's actually lime they use down there in the feed at the beef unit, but it's gonna do the same thing to the pH. So I'm gonna stir that up because when fertilizer runs off in there, the water's moving, and when I pour it in there like that, the water's not moving. So to get the water moving and get it mixed up real well, I'm gonna stir it a little bit. This right here is your pH tester, and this is like the computer screen that goes with it. Right now, this is a real acidic solution, so it's sitting on about 4 right now, 3.9. So I'm gonna take this, take it out of there. I'm gonna stick it in here. Y'all can see what that does to the pH. See it changing, it was at 3.9. So this was my regular pond water. As I said, it's around 7, 7.5. So right here I got some urea, which is nitrogen. They also use this animal feeds. The reason I used animal feeds is that way it was just readily available to me, and it has the same composition, basically. It's gonna do the same thing to the pH. So I'm sure most of y'all have used fertilizer sometime in your life. Has everybody used fertilizer sometime? And when you put fertilizer on, did y'all put it on top of the soil? Did you put it in the soil? Or was it a liquid fertilizer?
Our farm uses liquid fertilizers.
Liquid fertilizers. There's advantages and disadvantages with liquid fertilizers as far as application goes. It's a little bit harder process, I guess you could say, because you can't just take a fertilizer buggy out there and spread the fertilizer. So, but with pelleted pelleted fertilizer like this urea right here is kind of in a pellet. The disadvantage is because urea, once it's put on top of the ground, it can really easily disappear or transpitate. I think that's the right word. It kind of like evaporates, but water evaporates. This stuff just goes into the atmosphere. So when you put it on top of the ground like that, it disappears. What's really important to get a light rain or to wake the urea in the ground. That way you don't lose it. Y'all can see how the regular water starts around 7, 7.5, and I've added some lime in there, and now it's at around 8. And for y'all that don't know the pH scale, 0 is the most acidic you can get, and 14 is the most base numbers you can get. And around 3 to 2, around 4 into 3, my bad. Around 4 into 3, all your adult fish die. So, and then it just, as far away from 7, as far as from 7 to 0, or 7 to 4, as you go up, reproduction starts getting messed up with the fish, so they don't reproduce right, and then eventually they just end up dying. So I put the urea in this sample. Now I'm trying to just stir that up. And for you all that can't see that, y'all can pass that down if you need to. Now that's been in there close to 3 minutes. And obviously as you add more lime, it's gonna drop the pH make the pH more basic than it is right now. So I'm gonna take this out of here. I'm gonna wipe it off. I'm gonna wipe it off just to make sure it doesn't have any lime in there when I put it in the next solution. And now I'm gonna put it in here with that urea, stir it up again. And you can see the effect. I'm gonna put some more urea in there. That way maybe you can see a more drastic change.
It went off.
Does anybody have any questions?
So we talked about how acid can kill fish and acid can do all these different things. But what happens if there's too much space in, say, the water or anything such as that?
As far as that goes, when a drastic change happens in the water of the fish, it's going to obviously affect the fish in different ways. More acidic is going to kill them, and as it becomes more basic, it's going to also affect the fish, but it's going to affect the fish in different ways. I don't know if it's necessarily going to kill the fish, but obviously it's still going to affect the fish. Because I know we had a pond, and our pond was kind of acidic. This pond was kind of acidic, so we took ag lime and put in the pond to bring the pH level to more base. I think it's dissolved.
He's done.
Okay.